So as I mentioned in the previous video, we're going to read in the directions.txt file that we've written. And it's a very similar process to reading the locations, but the difference is I'm going to actually introduce a buffered reader. Now, a buffered reader reads text from the input stream and buffers the characters into a character array. So for our example, we're going to still create a file reader, but we're going to use it as an input stream for the buffered reader to use. Now, reading chunks of data from a stream such as a file is more efficient than reading just a few characters at a time. And the reason for that is because things like the overhead of seeking to the correct track and sector on on your disk drive are significant. So it actually takes a while to find the correct place on the disk drive to read from. And if you have to do that many times because only a few bytes are being read at a time, then the seek times for this really do add up. So consequently, buffered readers can be a lot more streamlined to, faster in other words, and more efficient. Now you can actually specify the size of the buffer, but the default is 8K bytes, and that's enough really for most purposes. Now our files here are both smaller than 8K, so what that means is the entire contents of the file will be read into the buffer in a single read and be available from there for the scanner to use it as it needs more data. So let's go ahead and look at implementing that now. So I've already read in the locations, as you can see here, starting on line 48. So actually starting on lines 46 to be precise. So let's go ahead and, as I mentioned, read the directions in. So I'm going to actually put that in its own try block. So I'm going to come right down here and actually add it into a separate try block. And bearing in mind, we are going to change this to a try with resources later. So let's start with that. So I'm going to try. So just put a note here that we're going to now read the exits. Let's maybe scroll up a bit so we've got a bit of space for the typing. And we're going to start with a try. We're going to start with scanner. Scanner equals new scanner, new buffered reader, and new file reader, directions.txt, which of course is the name of the file that we use to store our directions /exits in. So I'm going to accept those imports, or import, that's only the one, and we're going to set our delimiter, so scanner dot use delimiter, we're going to set that to a comma again. Then we're going to start our loop. So we're going to do a while scanner dot has next line. So we're going to just continue going through the entire file and read the location. So location equals scanner dot next int. Then we need to get the direction. String direction equals scanner dot next. And then we need to get the destination. So that's going to be a string. Before we do that, actually, we need to actually skip. So scanner.skip, scanner.next delimiter. And of course, we're doing that to go to the next, delimiter, not next delimiter, delimiter. We're doing that to go to the next comma because we've obviously read in the first one, which is the location, and then we're going to read in the direction. And I should have actually had a delimiter there as well, because obviously each piece of data, if you recall looking at directions.txt, we've got them separated by commas. So consequently, of course, we need to use that line scanner.delimiter to skip for each one of those. So I've got the location I'm reading on line 67. I'm skipping the direction that I'm skipping. And then the last one is going to be the destination. So string dest is equal to scanner.next line. So we're going to read just to the end of the line now because that's really the only data there. And then let's create an integer destination, and we're going to use integer.parse int dest. So we're actually just converting it to an integer because ultimately that's what it is going to be used for. Then we're going to just print them out. So let's do that. So it's going to be location plus a colon and a space plus direction plus colon and a space plus the destination. Let's build a location object. So location equals locations.get lock. So we'll get the locations that are on file for that, or the location, basically the location. And then we need to add an exit to it. So we can do location dot add exit, and direction. The exit can have a direction and the destination. So we're building up the destination object. And we haven't written that code yet for add exit, so that it's normal to expect there's an error there. And we need to catch our errors will catch a potential error, which is IO exception E, and we'll just do an E dot print stack trace. And I obviously need to put another bracket in there, so I'm in at the wrong level there. So that's fixed the catch up, and I'll just move the catch back to 1. Delete that. And E dot print stack trace. Then we're also going to add a finally. And the finally is going to be just close the scanner if it's open, if it's not null. So if scanner is not equal to null, scanner dot close. So what we're doing here is that the file reader is passed to the buffered readers constructor. This is on, I'm talking about line 64. Then the buffered reader itself is passed to the scanner's constructor. And once again, just want to point out the classes are designed to be used in this way, and closing the scanner will actually close the buffered reader. And that's of course because it implements the closable interface that we talked about in the last video. So we can check the buffered reader's closed method if we want to. And have a look for close. So we can see that it calls the close method, and it calls the close method of the reader. And if we just have a look at that, you can see in is actually a private reader in. So basically, again, what it's doing is it's implementing the closable interface, and therefore that close is automatically going to be called for the buffered reader. And if we just go up and have a look at the buffered reader, you can see that it's an abstract class and it implements readable and closable. So again, for that reason, it's going to basically be auto-closed once the processing's been completed for it. So again, closing that down and just looking at the code we've just written, we're basically going through and one field at a time extracting that field from the scanner, because obviously we used commas as delimiters, as I mentioned earlier in this video. So to read it back, we tell the scanner that it needs to use that comma as a delimiter. So of course it knows when to stop reading each piece of information. Now most of the body of the while loop is taken up in getting the integer string and the integer data from each line of the buffer. And reading data into numerical values from a text file can be problematic. And I had to read the final number as a string using the next line method. This is the code on line 71, because there's no comma delimiter to tell the scanner to stop reading an int, because that's really at the end of that particular line. And in fact, the scanner may not be the best way to parse this data. The thing to remember with scanners is they can be notoriously difficult to use, and it really can take some trial and error to get one to behave properly with a particular data set. Now in this example, we've had to skip over the delimiter when reading strings, as otherwise the delimiter is included in the string. And you can see I skipped it on line 68 and line 70. And the other thing is we've got an error when trying to call the location object's add-exit method. And that's because we actually removed the method when trying to make the class immutable in previous videos. So let's add the add-exit method back to the location class. But we're going to make a change there just to protect ourselves. So I'm going to come down here into location. We're going to add it. We're going to add it as protected, so that it's only available to classes in our package, and of course subclasses of location as well. So it's going to be protected void add exit, and it's going to accept a string for the direction and an integer for the location. And all it will do is put exits.put, so add it to our map and direction location. So it's a very simple method. Okay, so that's that added back. So if we go back now, that error should disappear on line 75 and we're good to go. So before I change anything else, let's actually run the program to make sure it works. So let's have a look at it. And you can see we've got our comments that, if you recall in the code, I actually added some output on line 49 to say we've imported the various locations. We've got the location number and the actual descriptions. And we've also got our location, our exits data as well. So that seems to have read that in and be working okay, which is good. So we've done that, but let's actually go now and run the code from the main class so we can actually run the program to make sure it still actually runs and works. So we'll do that. We can actually just move around to different locations in our game. Okay, so you're standing at the end of the road. So let's go north again. Go south again. Go east. Go west. And let's try and go east again. And let's try and go, say, north. Can it go in that direction? Let's quit. That seems to be working very well, which is fantastic. And obviously you can see that the code at the top there was actually printing out the locations data that was coming through when it was imported. So we can see that it's actually being read successfully from both the locations.txt file as well as the directions.txt file. Now another way to parse this data is to read it line by line, and then we could actually use the string class split method to get each part of the line into a string array. It's then quite simple to parse the values that really should be integers. So let's actually look at another way of doing that. So I'm going to close this down and go back to locations. And I'm going to comment out the code that we actually had in there. So comment out this code up until that destination line there. We'll comment that out. And we'll do something using the string.split. So the way to do that would be string input equals scanner.next line. That's read the entire line this time rather than reading sort of one of three fields, which we've done on lines 67 to 72, which I commented out now. So we've read basically the entire line, and then we can do string data is equal to input.split, and then we use our delimiter character, which was a comma, and that creates a string array, which has now got each one of the fields from that line in there for us. And now what we can do is we can put input for the location. We can say it's integer.parseInt, and we'll say it's the first array element. Then string direction is equal to data1, because we're keeping that in a string format. Then int for the destination, that's going to be equal to integer.parseInt. That's going to be data2, the third part of the array. Then these lines here, on lines 79 through 81, they're unchanged because I'm still taking the same variable names and being processed. So just run this to make sure that it works again and we can still run our game. So that's still working, which is good. So that code there is probably a bit easier to understand and also can be easier to implement when we're dealing with data that's separated in some way. So at this point, you might be thinking that we're back where we started and we actually have more code than we had before. So what is the actual advantage? Well, with the small number of locations that we have at the moment, the advantage is not really obvious. But I've actually, in the next video, I've got a download for you in the resources section of the video, and we're going to use those files instead because they've got a lot more locations. And as a result, you'll sort of see the advantages, when you're dealing with larger text files. So let's end the video here now, and in the next one, we'll go ahead and look at implementing that data so that we can actually run the game with more locations. See you in the next video.